Hello, everyone. Let's talk about section 5.4. And this is about, actually, that's the wrong title. It's right triangle trig is in fact what this is. Anyway, how many people actually read that, but there you go. That's the actual title for this section. So anyway, I think I've mentioned this before, but just to reiterate this, the basic definitions for sine, cosine, and to help students remember the definitions of the different trig functions, and that word is SOHCAHTOA. And so here we have a picture of a right triangle. The angle that we are interested in, we're going to call that angle T. Because it's a right triangle, it has a right angle in it, obviously, and the side across from the right angle is the hypotenuse. The one that's next to the angle, the other side that makes up the angle in question, is the adjacent. And then the one that is across from it here is called the opposite. And so SOHCAHTOA is just designed to help you remember that sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. That's what CA is telling you. And then tangent is the opposite over the adjacent. So again, the little kind of goofy word is SOHCAHTOA, which it kind of rolls off the tongue very nicely there. So SOHCAHTOA is to help you remember which trig function goes with which ratio of sides. Opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. So with that in mind, we can then find various trig ratios based off of the definitions of the different trig functions. So if we look at this triangle right here, here is side T. The side opposite that is equal to 7 in this case. The side next to it, the adjacent side, is 24. That's the adjacent right there. And then the one across from the right angle, which also incidentally will be the longest side. If you have a hypotenuse that is shorter than the two legs, that's a problem. But anyway, that's a different issue. So anyway, the hypotenuse is in this case 25. And so if we want to write the value of sine t, so sine of t, that's going to be defined as the opposite over the hypotenuse. That's again just based off the definition of SOHCAHTOA. What that means is, in this case, the opposite side is 7, the hypotenuse is 25, and there you go. The answer that we're looking for is 7 over 25. That's it. So kind of, hopefully you'll agree that's kind of an easy one to kind of get the ball rolling here. What else do we have? So let's see. So the moral of this story is we've got these two different angles here. So we've got this, which is the Greek letter alpha. That's the Greek letter alpha. And then there's this thing, which is the Greek letter beta. For those of you who are not up on your ancient Greek, or maybe even modern Greek too. I don't know as much about the modern Greek alphabet, but anyway, what this is trying to get across to you is this. So here is angle alpha, and the one that is across, that is opposite alpha, is that one right there. And the one that is adjacent to alpha is this one right there. The hypotenuse is the same no matter what you do, because the hypotenuse is always across from the right angle. And the moral of this story is just that, let's do, I don't know, green. So then this right here is angle beta, which is the other angle over here. And the thing to notice is that if you go across from beta, there's this side, which is the opposite of beta. And then the one that's next to beta is this one right here. And so the moral of this story is that depending on your point of view, depending on which angle you're talking about, the opposite and the adjacent can change. That's the takeaway from this. So opposite and adjacent depend on which angle you are referring to. I'll even write that down. So opposite and adjacent can change depending on which angle you are using. So just be aware that opposite and adjacent have like an identity crisis. Depending on the situation, they could be different. So given the side lengths of a triangle, you can evaluate the 6 trig functions for one of the acute angles. So drawing a picture is usually a good idea when doing trig problems if they don't provide you with one. So it's good to know the angle, the adjacent side, and the opposite side, as well as finding the hypotenuse. And then here you've got all the different trig functions and their definitions. So the secant is the reciprocal of cosine, and then the cosecant is the reciprocal of sine, which I believe we've talked about before. It's kind of a blur given how long ago that was. But anyway, the reciprocal of cosine is the secant, and the reciprocal of the cosecant is the sine. And so really just know that if you want the secant, the cosecant, and the cotangent, you're just going to flip the fractions upside down for their respective basic trig function, the main trig function, the trig functions that get the privilege of a calculator button on them, shall we say, the main ones, sine, cosine, and also tangent. So anyway, here we go. Here's a very lovely right triangle, and they say, hey bro, give me all of that. Okay, so we can do this. Here is the angle T. The hypotenuse is the easiest one to identify, and the hypotenuse conveniently never changes. The hypotenuse is 65. The one that's across from T, that's the opposite side. We'll call it op for short because the word opposite, hypotenuse, and adjacent are too long, and I've got bigger fish to fry than showing you all how I can't spell. But anyway, the adjacent side is this one right next to it here. So we'll call this edge. And so again, remember, so, ka, toa. If you learn nothing else from this unit, know that it is the cornerstone that all of trigonometry is built upon. So anyway, let's do this here. It's going to be awesome. Here we go. All right, the sine of T. That's going to be the opposite over the hypotenuse, 33 over 65. Okay, the cosine of T. Let's see here. That's going to be the adjacent over the hypotenuse, 56 over 65. And then the tangent of T is the opposite over the adjacent, so 33 over 56. And then cosecant goes with sine, secant goes with cosine, and then cotangent goes with tangent. And I think I might have shared this with you all before, but just bear in mind, there's only one co-function for any pair. So cosine goes with a secant, cosecant goes with sine, and then tangent goes with cotangent. That one's kind of the more obvious one. but just, it's the easiest thing in the world and students mix it up all the time. So just, I'm telling you here and now, don't forget this, cosecant goes with sine. Secant goes with cosine. A co-function does not go with another co-function. Anyway, let's see. So what we're going to do here, we're just going to flip the fractions over. So we're going to have 65 over 33. We're going to make this 65 over 56. Flip this one upside down. We get 56 over 33. And there you go. Woo, look at that. I've got a bit of a sore throat, so you'll have to bear with me here. But there you go. We've got all 6 trig functions for that angle T. All right. Find the exact value of the trig functions of pi over 3 using side legs. Okay. So we talked about this in section 5.2, but for those who don't remember, let's draw ourselves a little picture here. So this is pi over 3, and in degree land, that is 60 degrees. Because fun fact, pi is 180 degrees. That's what that's equivalent to. And if you do 180 and divide it by 3, that'll get you 60 degrees. Across from 60 degrees is root 3 over 2. That goes back to some relationships that you might have learned way back when in geometry, but just bear in mind that whatever's across from 60 will be root 3 over 2. Meanwhile, the one that corresponds to root 3 over 2 is going to be 1/2. And then what you might recall is that the hypotenuse of the unit circle is 1 by definition. So let's go ahead and label these here. So if our angle is down here, we're going to have this one is the opposite side. This one here is the adjacent side. And then this one here is the hypotenuse. So here we go. We're going to say the sine of pi over 3 is equal to root 3 over 2 over 1. Let's write this slightly differently. We'll call this root 3 over 2 divided by 1. And fun fact, if you divide something by 1, it doesn't actually do anything. So really, this is just root 3 over 2. Meanwhile, cosine of pi over 3, the adjacent side is 1/2, and then you put that over the hypotenuse, which is also 1. And fun fact, 1/2 divided by 1 is 1/2. Meanwhile, if you're going to do the tangent of pi over 3, well, the opposite side is root 3 over 2. And the adjacent side is 1/2. Now, if you're going to do tangent, you're going to divide the top by the bottom. So I'll show you this the long way, and then I'll teach you all kind of a shortcut here. If I have root 3 over 2 and I'm dividing that by 1/2, well, what you're supposed to do when you're dividing fractions is you're supposed to multiply the reciprocal. So you're going to have root 3 over 2 times 2 over 1. And then fun fact, this 2 will cancel out with that 2. And what will be left is root 3 over 1. And then being over 1 doesn't do much. So when all is said and done, it's equal to root 3. A shortcut that I like to use is, since you've got this over 2, you can actually cancel out the over 2 from top and on bottom and just kind of cut to the chase here and know that that gives you square root of 3. So you've got kind of the long way, the proper way, And then you've got kind of the quick and dirty little shortcut that that I kind of like to use. And this will not be the first time you see me use it either. So, all right, I think it was a bit overly optimistic that I would fit both of these on one slide, but let's write down what we have so far here. So we've got, or actually, let's continue on and then we'll write them all down together when we're all done. So what do we have? We have the cosecant of pi over 3. That's the reciprocal of sine. Sine goes with cosecant. So if we do the reciprocal of sine, that's going to give me 2 over root 3. Now, square roots on the bottom in the denominator, that's kind of frowned upon. So what we're going to do is rationalize the denominator here. We're going to multiply root 3 on top and on bottom. And when we do so, 2 times root 3 is 2 root 3. Root 3 times root 3 is going to give you just plain old number 3. And there you have it. The value for cosecant is going to be 2 root 3 over 3. Meanwhile, for secant of pi over 3, remember that secant is going to be the reciprocal of cosine. And so for cosine, cosine is 1/2. We're going to flip that upside down, make it 2 over 1. This one's a lot easier than the other one because 2 over 1 is going to give you the number 2. Lastly, the cotangent of pi over 3. If we do the reciprocal of tangent, that's just going to be 1 over root 3. That is the reciprocal of the root 3 that we got earlier. And then what we can do is we can multiply the top and the bottom by root 3 to rationalize the denominator. And when we do, we get root 3 over 3. So when all is said and done, let's cross this out for right now. And we'll do a separate slide with that example on it. It was a little overly optimistic that I would fit both of these on here. But anyway, so let's write this down. So we've got sine of pi over 3 is root 3 over 2. And then cosine of pi over 3 is 1/2. And tangent pi over 3 is root 3. And then cosecant of pi over 3 is 2 root 3 over 3. And secant of pi over 3 is the number 2. And then cotangent of pi over 3 is root 3 over 3. So there you have it. All of that. That's all 6 trig functions of that angle. All right, so now what we're going to do, let's copy this slide. And then we will erase all of the scribbles and then do the example that I crossed out. All right, out of curiosity, is that, yeah, that's all one thing. All right, let's, I'll move that over there. And let's see, all right. So, all right, let's do this, shall we? So pi over 4, what's that going to look like? Let's break out our unit circle again. So here's pi over 4, which is equivalent to a 45-degree angle. Anytime you have a denominator of 4 for your radian angle, your radian measure, that's a special situation where it turns out the sine and the cosine are exactly the same. So that means that the side that's across is root 2 over 2, and the side that's next to it is also root 2 over 2. So this one is the adjacent. This one over here is the opposite. And then the hypotenuse for the unit circle is always 1. So this is the hypotenuse, which is 1 right there. And let us see what the different trig values are for pi over 4. So if you do sine of pi over 4, that is going to be root 2 over 2. Let's do this again. Root 2 over 2 divided by 1, which is just root 2 over 2, because as we mentioned earlier, dividing by 1 isn't terribly exciting because it doesn't do anything. Meanwhile, you can do the cosine of pi over 4, which, fun fact, since the opposite and the adjacent are the same, this is going to look exactly like sine, because you do root 2 over 2 divided by 1, you still get root 2 over 2. For the tangent, what's going to happen? You will do the opposite over the adjacent. So you do root 2 over 2 and divide it by root 2 over 2. Well, fun fact, if you divide anything by itself, you will get the number 1. So if you take root 2 over 2 divided by root 2 over 2, you will get 1. Meanwhile, let us find some reciprocals, shall we? So the cosecant, that's the one that goes with sine, remember? The cosecant of pi over 4, if you flip this upside down, you will get 2 over root 2. And as I've mentioned previously, we don't much care for square roots in the denominator. So we're going to multiply by the square root of 2 on top and on bottom. When you do that, you will end up with 2 root 2 on top, and root 2 times root 2 is the number 2. Well, guess what? 2 over 2 is going to cancel out and reduce, so that when all is said and done, what you are in fact left with is the square root of 2. The secant of pi over 4 is going to be much the same story, as this is also 2 over root 2, which you do the exact same thing, and you're going to get root 2 for that one. And then fun fact, if you do the reciprocal of 1 for tangent, that's 1 over 1, which is still the number 1. So if we were to then summarize all this, sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. The tangent of pi over 4 is equal to 1. The cosecant of pi over 4 is the square root of 2. The secant of pi over 4 is also the square root of 2. And then the cotangent of pi over 4 also happens to equal 1. So there you have it. There is that one. All 6 trig values. Okay. What else do we have going on here? So here we have co-function identities. So fun fact, it turns out that cosine of t is in fact equivalent to the sine of pi over 2 minus t. And that's true for all these. So you can then, if you reverse it, sine goes to cosine, tangent goes to cotangent, secant goes to cosecant. These are all the co-function identities. Now, something I will point out to you, and actually let's, instead of the unit circle, let's just draw a triangle here. So the first thing I will note, recall that pi over 2 is equivalent to 90 degrees. Yes, pi over 2 radians is another way of saying 90 degrees. And you also hopefully recall that the angle sum in any triangle, not just right triangles, the angle sum in a triangle is 180. Now, if this one, the right angle, is fixed at 90 degrees, if this one's X and this one's Y, what that tells you is that X plus Y need to together make up the other 90 degrees. And so that just means Y is 90 minus X and X is 90 minus Y. And if you change this back from degrees to radians, that's where all of these are coming from. And one other thing I will point out to you, where the name cosine comes from, the function cosine is itself an abbreviation for, it literally means the complement of sine. And then what you might recall is that angles which add to 180 are, or I'm sorry, angles that add up to 90 are called complements. Angles that add to 90 degrees are called complements. And so there's some formulas there, and you can, make use of them as you see fit. Since I let you use notes on your test, you can, you don't necessarily have to have these memorized per se, but that's what the formulas mean, and that's where they come from. And in fact, the very word cosine, what it means is it is the complement of sine. And so if you go back and forth between the complementary angles, like 30 and 60, or 80 and 10, or 70 and 20, whatever, if you have pairs of angles that are complements, the sine of 20 is equivalent to the cosine of 70. That's, in a nutshell, what this is telling you. The sine of 70 degrees is equivalent to the cosine of 20 degrees, is what that effectively means. Here we're talking about it in terms of radians, but this is kind of the general idea. Okay. If sine of t equals 5/12, find the cosine of pi over t. Well, fun fact, the sine of t happens to be equal to the cosine of pi over 2 minus t. That is one of the formulas you would find on the previous slide that we were just looking at. So guess what? Because sine of t equals 5/12, guess what? The cosine of pi over t, or pi over 2 minus t, is the exact same thing. Ta-da! How about that? If cosecant is 2, find secant of pi over 3. Now, the cosecant of pi over 6 is going to be equivalent to the secant of pi over 2 minus pi over 6. Now, fun fact, if you get yourself a common denominator by multiplying, I don't know, 3 right here, that will give you 3 pi over 6 minus pi over 6. Fun fact, 3 minus 1 is 2 pi over 6. And you can reduce that. You can divide those both by 2 and get a 3 down there. And if you do, that just gives you pi over 3. So long and short of it is, this is the secant of pi over 3. So essentially, this is equivalent to the exact same numbers. So secant pi over 3 is also equal to 2. How about that? So the complementary value is going to give you the exact same ratio if you change back and forth from the function to its cofunction. Let's see. A right angle has one angle of pi over 3 and a hypotenuse of 20. Find the unknown sides of the and angle of the triangle. Okay. Well, let us draw a picture, shall we? Here we go. That's a little tall, but okay. Here we go. So this one down here, this is pi over 3. And you might recall this. So when it's across from pi over 3, aka 60 degrees, 180 divided by 3 is 60. So this side is root 3 over 2. This side is 1/2, and this side is 1. Now they tell us that the hypotenuse is 20. So what that means is that to go from 1 up to 20, we need to multiply this number by 20. And if we do that, then we need to multiply this by 20 over here. And we need to multiply this by 20 over here. Because if the hypotenuse is 20 times bigger, all of the sides need to be 20 times bigger to maintain the ratios of the side lengths of that triangle. So what that tells me is the hypotenuse is 20. This side down here, which is the adjacent, 1/2 times 20 is the number 10. And then here, 20, cut it in half, you'll get 10. This is going to be 10 root 3. And this, incidentally, is the opposite side. So they say find the unknown sides and angle of the triangle. So we've got this angle up here that we do not yet know. But here's what we do know. So we've got a hypotenuse of 20. We have an opposite side of 10 root 3. We have an adjacent side of 10. And then angle X, if X is going to be pi over 2 minus pi over 3. And let's see, if we get a common denominator, multiply this by 3, multiply this by 2. If you do that, that will give you 3 pi over 6 minus 2 pi over 6. 3 minus 2 is 1 pi over 6. So the missing angle is pi over 6. And then we have the 3 sides right there, 10, 10 root 3, and 20. All right, so we know all the missing pieces of that triangle. Oh, what else do we have? We have a word problem. Or, well, we have a description of how to approach word problems. All right, so an angle of elevation just means that if you're flat on the ground, then if you're going to turn like this, that's the angle of elevation. Or if you're like talking about an airplane and like you're gonna do your descent or some such, that would be the angle of depression. And fun fact, the angle of depression is going to equal the angle of elevation due to geometry reasons. But fun fact, the angle of depression and the angle of elevation are going to be equal. And so in case you're ever wondering, like, you can look, I don't know what it is, but if you look it up online, like you can figure out how tall Mount Everest is. And I got news for you. The way people figured that out was they didn't send somebody up there, throw down a tape measure and say, "What's it say, bro?" Or like, like how tall, like really tall trees or buildings are, anything like that. What you can in fact do is instead, if you have, there's a little, I forget the name of it, there's a little doohickey where it looks kind of like a telescope, but it's got like a weight, and it'll, as you turn it up, it'll actually show you the angle that you're pointing when you point your telescope or whatever into the air. And so if you can figure out the angle, which there's a way to do it, and if you can measure the horizontal distance, then what you can do is break out the magic of trigonometry to then figure out how high something is that's really tall. And so there's a way to do that using trigonometry, which I think is pretty awesome. All right, so to find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees between the line of sight to the top of the tree and the ground. Find the height of the tree. And they very conveniently have a picture for us for this situation here. So we want to know how high this tree is. So this is H right here. And so when you're doing a word problem, the thing to bear in mind is SOHCAHTOA. And so what SOHCAHTOA will do, depending on the side you know and the side you want to know, you can use those two pieces of information to figure out which trig function is appropriate for the situation that you're describing. So in this case, the angle is right there, that's 57. This side, the 30, that is going to be adjacent. And then the other side over here is going to be the opposite, because we want to know the height of this tree. And we look at this and we say, okay, I know the adjacent and I want the opposite. So the one that has opposite and adjacent is going to be tangent. So the trig function that I need to use to solve the problem is going to be the tangent. The angle in question is tangent 57 degrees. And that should be equal to whatever the opposite side is, which I've called H, I don't know what that is, divided by the adjacent, which happens to be 30. Now, how will we solve this equation for H? Well, since you are dividing by 30, what you would need to do is multiply by 30. You're going to multiply both sides by 30. That will then let you cancel those out. And then basically what this means is that the height is 30 times the tangent of 57 degrees. And then what you do is you break out your friendly neighborhood calculator. Make sure you change it to degree mode first. So let's see, I'm going to go to mode, change it over to degree mode. If I do tan 57 in the calculator in degree mode, that will give me the decimal 1.5399 if I round it off. And then they don't tell me how far to round, but okay. So we're going to multiply that answer by 30. And if you do, it's roughly 46.2 feet. Oh, man. So there you have it. The height is 46.2 feet. So that is a word problem where you can use trigonometry to find out how tall things are. And we've got one more example before we're done with this section. So let's look at this. It says how long a ladder is needed to reach a windowsill 50 feet above the ground if the ladder rests against the building, making an angle of 5 pi over 12 with the ground. And then they say round to the nearest foot. All right, let us draw a picture for this situation. So we have a building with a windowsill. So we've got there you go, there's your building. And we're gonna have a window like, I don't know, up here somewhere. There you go, there's the window. And we're gonna, let's see, the window is 50 feet above the ground. So from here to there, that is 50 feet. And then we have a ladder that's going to be against the building here. So we'll have a really bad drawing, but okay, there you go. There's your ladder. And we need to know how long this ladder needs to be. And they tell us the angle that it makes, which we're back in radians now. This is 5 pi over 12. So this angle right here is 5 pi over 12. Let's maybe try to write that a little more neatly. Okay, so we have the angle. This side over here is going to be the opposite. This side right here is going to be the hypotenuse. So then again, if we go back to SOHCAHTOA, if we want, or if we have the opposite and we want the hypotenuse, the one with opposite and hypotenuse is sine. So what we're going to do is we're going to do the sine of 5 pi over 12. And that is going to equal the opposite, which is 50, over the hypotenuse, which is x. Okay, if we were to solve this, we would do something similar to what we did last time. We would want to multiply both sides by x. And so that will give me x times the sine of 5 pi over 12. And I will work that out later, but the thing to remember is that sine 5 pi over 12 is going to be some sort of number. It's going to be some really gruesome, nasty looking decimal. So you've got x times a number equals 50. How will we solve for x? Well, we divide by whatever that number is, yes? So you divide by the sine of 5 pi over 12. You do that over there, and then you do that over here. And let's see, if you do that, x is going to be equal to 5 divided by sine of 5 pi over 12. So in the calculator, make sure you go, whoop, don't turn it off on me. Make sure you go back to radian mode. Make sure.
Sir,
Yes.
can we substitute pi by 180 degree and cancel out the 5 pi over 12? If you substitute the pi, can we do that, or we have to use to the 3.14?
Well, if that would be a valid way to do it, and then you would, if you're gonna do it in terms of degrees, you just want to make sure the calculator you're using is in degree mode. But that actually is a perfectly valid way to do it. You could do the sine of 5 times 180 divided by 12, and as long as you're in degrees, that would also work.
All right, thank you.
Sure. Let's see here. So let's find out what that is. And again, I'm going to work it out in radians, but even if you do it in degrees, like the decimal it gives you should be exactly the same. What that works out to be is 0.9659. So X is going to approximately equal 50 divided by 0.9659. And even if it's in degree mode, like that decimal would be exactly the same. So then let's see here. We're gonna do 50 divided by that number we just got. And they ask us to, so X is going to approximately be 51.76. And then since they say round to the nearest foot, we're basically gonna say it's roughly 52 feet. But that is a valid point. If I mean, if you leave the calculator in degree mode, you could, if you wanted to, put in 180 for pi and do it in terms of degrees. But either way you do it, you should get the same answer when you're finished with the problem. Okay. So that is the end of that section. So it's just shy of 8 o'clock. So let's start up again at 8, and we will go on to the next section from there.